So hello everyone, welcome to our new video. Today we are going to learn about dynamic memory allocation. So dynamic memory allocation, what it is actually. So whenever we are creating any variables or any objects, then there are two different ways of creating memory. One is static and the other one is dynamic. Regularly, whatever the variables we create for integers, for float, for an array or whatever may it be, all those are created in a static way, so they are called as static memory allocation. But here today we are going to talk about dynamic memory allocation. So now this dynamic memory allocation, what it is, suppose if we don't know how much memory is actually required, suppose if you want to take some numbers from the user and give the user the sum of all those numbers. Now here we don't know how many numbers is the user going to enter. So suppose just a random number 100, I created a array of 100 integers. Done. Now suppose if a user comes and the user wants to enter 101 numbers. Now in that case 100 till 100 it was okay, but one extra number I cannot store that number. So what to do now? We don't have any idea. Second thing, suppose if the user wants to enter only 5 numbers. We have created a memory for 100 integers, but the user is only willing to enter 5 numbers. So in that case, what are we going to do? We can't do anything. I created some memory, some space for 100 integer variables. So in all these different type of cases, similarly whenever we are dealing with linked list, we cannot just randomly create a linked list of something n size. Their linked list is about creating a new node every time. We don't know how many nodes a user wants. So there again comes the need for dynamic memory allocation, that creating a node and then storing the address of that node somewhere to any previously existing node. So here in C programming allows us for 4 different functions for dynamic memory allocation. Now those functions are malloc, calloc, realloc and free. The first one we have malloc. Now this malloc function, it takes input parameter as the size, how much size of memory is required. Now whatever the size we provide it with, it creates a variable of that memory size and returns a void pointer of that memory. Similarly, calloc creates a memory and it also assigns some value into those memory. Third one we have realloc. Suppose we have created a variable, we have a fixed size. Now later on the user wants to change the size. Maybe the user wants to increase the size or maybe the user wants to decrease the size. So in that case we can use a realloc function. The realloc function takes 2 parameters. The first one is the pointer, the address of the previously allocated memory, and the second one is the new size, and the last function is free. Suppose we have created a memory, we have used that memory, now later on we don't have any use of that memory, then it is very important and very necessary to release the memory whenever we are using anything. So this is it only for the theory part. So now I will write a program and show you how we can use the malloc function in C language. So here, now what is the first line here? We write here as hash include stdio.h. We have the main function, return 0. So here, let's take the same example and let's take some input from the user. And let's first ask the user that how many numbers the user wants to enter here. So printf enter the number of values. Whatever the user enters, we need an integer variable n. Scanf %d %n. Now we want to use the malloc function. The malloc function, it does not exist in the standard input output library. So here we need to include another library here, stdlib, standard library. Now inside this we have the malloc function. So malloc, as I said, it takes the size, how much size is required. So here the user wants to enter integer values. So how many integers? There are n integers. What is the size of an integer variable? So we are going to use the size of function, pass the integer value here. Done. Now, as I said that it returns a pointer. It returns a void pointer. So I have created a pointer variable here. Now, whatever it returns, I am going to store it in the pointer variable, and also we have to convert this memory into a integer one, and it is done. Now we are going to ask the user for the inputs, that what are the input values here. So here we don't know what is the number of elements. Whatever it is, the user will be entering and it will be stored in the variable n. Now using this variable n, we are going to execute a for loop, and at every iteration we will take the input from the user as well as store it in the sum variable. So I have this sum variable here which is equal to 0. Now here comes the first thing, take the input here, scanf %d, comma. Now here either we have to write here as star ptr plus I, or also instead of this we can write here as ptr of I, because this is going to behave as a pointer variable, and at every iteration sum plus equal to ptr of I. So this for loop will take all the input from the user, and as well as it will do the sum, and it is going to store the value in the sum variable here. So now here let's print the sum here. So sum is %d, comma, replace this with the sum variable, and it is done. Let's execute this and see how it works. So let's say if I want to enter 5 values here, I have given the number of values 5. Now I have to enter all the values 6, 8, 7, 2 and 1. So if I want to check the sum here I have 10 plus 14, total I have 24. So it is giving me the sum here as 24. It is working perfect. Now two things I have not done yet. Now what are those? The first thing, whenever we are requesting for some memory, now if that amount of memory is not available in our system, then it is going to return a null pointer. Now if it returns a null value there, then it is not going to do any operations. Whatever we have written here, taking the input, storing it in the array, and then finding the sum, it is not going to work there. So here, every time when we request some for any memory, then we have to check here if whatever be the name of the pointer, if ptr equal to null, then in that case give an instruction to the user as unable to allocate memory, done, return 0 over. Because why have I written here is return 0? Because we know that the memory is not allocated, and there is and doing all these operations is of no use in this case. And at last, when we have used all the memory here, so here use the free function, pass the pointer variable, and it is done. So this is it about the malloc function. Let's execute. Let's enter the value. Number of values here is 7. The values are 7, 4, 1, 2, 5, 8, and let's say 9. Done. Now if I check the sum, here we have 10, 20, 20, 20, 20 plus 16, we have 36 here. So the sum it is giving us here as 36. So this is it. So this is it about the malloc function. In the next couple of days, we are going to record videos on the other functions and we are going to upload them. So please stay tuned, and to get the notification, please don't forget to subscribe to our channel and don't forget to press the bell icon so that you get a notification whenever we upload a new video. Now if you have any doubts, please give us a comment in the comment section. We will definitely get back to you. And if you have liked the video, please hit the like button because that gives us a motivation to make new videos every time. So thank you very much. Keep learning. So hello everyone. In the previous video, we discussed about dynamic memory allocation, and along with that, I also showed you how to use the malloc function, which stands for memory allocation. So in today's video, we are going to look for the calloc and realloc functions. Now what is calloc? Calloc function is almost similar to malloc. Here calloc stands for continuous allocation. Now what is the difference between malloc and calloc here? Now the major difference here is calloc initializes some value to the memory that has been allocated. Whenever we are using malloc function does not initializes anything. It just allots us a memory, or maybe we can say it as a plot of land somewhere. What is there on the plot of land? There can be anything. It can be a mountain, a river can be flowing from there. There may be some kind of garbage, or there may be some kind of a building if we talk about in terms of plot. But if you are talking about in terms of plot, while taking calloc function, so calloc function is like it just replaces everything with a 0. Each and every bit in the memory, it replaces everything with a 0. So here if we have a plot of land, so it is going to clear the entire plot of land and then it is going to give us that plot of land here. So that is what is the main difference between malloc and calloc here. So now let's write a program on calloc function and see how it works. So here we have the main. So I am going to take a variable n, which is going to take the size, and a pointer variable which is going to store the address of the allocated memory. Then let's take the input from the user. Let's give instruction to the user here. Enter the size of the array. Then let's take the size here. %d, %m%n. Done. We have taken the size here. Now we are going to call the calloc function here. While using the malloc function, it was just taking the total size as a collective one argument. If we need size for 10 integer variables, so 10, and per integer variable it allocates 4 bytes, so 10 into 4, we had to give there the size as 40. But here calloc takes two parameters, where the first one is the total number of items that we are going to store there, and the second one is the size of whatever the type of value we are going to store there. So now calloc, we need the size here as n, comma, and let's say if it is an integer array, so use the function size of int, and it is done. Now we need the pointer variable to store the address, and as I have said before for malloc, here also similarly calloc returns a void pointer, so we have to convert this into integer type, and it is done. Then as I said, every time we should check if the memory was not allocated. If the allocation was failed, then it is going to return a null. So if ptr is equal to null, give instruction here, unable to allocate memory, and then return 0, because we know that we are not going to do any operations if the memory is not allocated. Then let's ask the user for the values that has to be stored in the array. So enter the values, then take a for loop here. Int I equal to 0, I less than n, I plus plus, and every time we have to write a scanf statement here, %d comma ampersand ptr of I. Done. We are done here with taking the inputs. Now let's display the inputs and see if the values are getting stored or not perfectly. Printf elements in the array are another for loop, int I equal to 0, I less than n, I plus plus, and then write a print statement here. And it is done. This is going to print all the values that we have in the array. And at last, we should never forget that we have to release the memory after using that memory. So use the free function, pass the pointer here, and it is done. This is it. So let's execute this program. So let's say the size is 6. My numbers are 7, 4, 1, 9, 6, and 3. Enter, and here it is printing the same thing here again, that the elements in the array are these 7, 4, 1, 9, 6, and 3. So this is how we are going to use the calloc function. Now if you have any doubts, please give us a comment in the comment section. We will get back to you. And let's now continue with the realloc function. So now this realloc function, why it is used for? So it is in the name itself, realloc, reallocation of the memory. Suppose if I have requested for some memory, I was provided with that memory, but later on I saw that I need to expand the memory, or maybe I need to reduce the memory that I am using there. So there we can use the realloc function. Now this realloc function takes two parameters. The first one is the pointer variable, which is storing the address of the previously allocated memory. And the second thing is the new size. What is going to be the new size of the reallocated memory? Suppose before I am storing 5 integers, but later on I want to increase the size by 2. So my new size will be then a 7. And similar to malloc and calloc, realloc also returns a void pointer. So here also we are going to store the address, even though the address is going to be the same. Okay, so now let's look here and write the program. So I have the pointer variable here. I have two variables, n1 and n2, for the size. Give the instruction to the user, enter the initial size of the array, scanf %d comma ampersand n1. Done. Now we are going to use the malloc function here. If you remember how it was taking the size, n1 into size of integer, and it was returning an address here. So store it in the pointer variable and convert this into integer type. Done. And every time it is very necessary for us to check if the pointer variable is storing a null value. If ptr equal to null, printf unable to allocate memory, return 0. And here now let's take the input from the user, printf enter the values, take a for loop here, int I equal to 0, I less than n, I plus plus, sorry, the size here will be n1, then scanf here, %d, comma, ampersand ptr of I, done. Then let's just print the initial values, elements in the initial array, take a for loop here again, where I is going to start from 0 till n minus 1, n1 minus 1, and I plus plus, printf, the values are %d, double space, comma, ptr of I, and it is done. We are done with this. This is what we were doing while using malloc. Now we are going to use the realloc function. So ask the user to enter the new size of the array. The user is going to enter some value, %d and %n2, which is our new size here. Then the same statement here also we have ptr equal to int star, and then call the realloc function, pass the values here, the pointer variable, comma, and the new size, that is n2 into size of integer, and it is done. Then let's say everything is looking good. Now as every time, check if it is not null. If it is null, then printf unable to allocate memory, return 0, and then ask the user to enter the additional values. A for loop here, but this time instead of starting it from 0, it is going to start from n1, and it is going to end at n2 minus 1, I plus plus, then scan the values here, %d, comma, ampersand of ptri. Now here also we are done with taking all the inputs from the user, the additional inputs that we had to take here. Now let's print the values here. Printf elements in the new array here. For printing everything, the array is going to start from 0 till n2, and I plus plus, printf the values here, %d, comma, ptr of I, and at last release the memory here. So this is it about how we are going to use the realloc function. This is it about the realloc function. Now let's execute the program and see how it works. So let's give here our initial size, let's say 6, 7, 4, 6, 0, 3 and 8. These are my initial values, 7, 4, 6, 0, 3 and 8. Now let's enter the new size here. Let's say 8, 2 more extra values. My 2 more extra values are 9 and 15. So here I have the new array and everything is getting printed here as it is. First I had the values here 7, 4, 6, 0, 3 and 8. Here we have 7, 4, 6, 0, 3 and 8. And then I had the new values here 9 and 15. Here I have 9 and 15. So this is it about realloc function, and also this is the concluding video for dynamic memory allocation in C. We have covered malloc, calloc, realloc and free, all these 4 functions. Now if you have any doubts, please give us a comment in the comment section. We will definitely get back to you. And if you have liked the video, please click the like button, because that gives us a motivation to make new videos every time. And if you have not subscribed to our channel, please subscribe and don't forget to press the bell icon so that you get a notification whenever we upload a new video. So thank you very much. Keep learning.